Hello, everyone. Brian Gockel here, Office of Observations, Weather Service. Welcome to the Satellite Book Club Seminar Series. This is session number 240. Today's presentation is the May 2025 Eastern U.S. Atmospheric River event, presented by Chris Smith, the GOES-R Satellite Liaison. Our facilitator today is Andy Lotto from NESDIS Geo. A few reminders before we get underway. Session is being recorded. Please see the pinned message in the chat for Privacy Act information. As usual, we'll have Q&A after the presentation. Please post your questions in the chat. Use your full names to include full names when asking a question, please. Are you interested in presenting? Please fill in the form in the chat. Link will be dropped in there. You should be seeing it in the meeting chat. Training assistance is available. Development of training materials, locating training materials. Please contact Ross Van Til. He can help with that. Thanks to the OCLO, the GEO and the LEO programs for their support, and the TowerS team putting this together. Emily, Kashad, Lee, and most recent group lead is Sheila. Welcome back. Sheila's been with the TowerS team before, and we're glad she's back with us again. Before we get underway, quick introduction to Chris. Chris Smith, most of you know him. Chris graduated from the University of Maryland with a master's degree in Atmospheric and Oceanic Science. Chris's first role was as a contractor with the NESDIS Office of Systems Architecture and Engineering to maintain and update NOAA's user observation requirements that inform the organization's observing system architecture. That group, SAE, is one that the Office of OBS interacts with regularly. Chris joined the Cooperative Institute for Science Earth Satellite Systems, CISESS, as the GOES-R Satellite Liaison for OPC and WPC. That was in October 23, he made that transition, and he's helping make satellite imagery and products available to forecasters while also delivering user feedback to the product developers to maximize product capability. Chris, welcome back to the Satellite Book Club.
Thanks for the introduction, Brian, and I'll get started here. The GOES-R Satellite Liaison for the Weather and Ocean Prediction Centers here in College Park, out of the Cooperative Institute for Satellite Earth System Studies, or CISESS, and I'll be talking about the May 2025 Eastern U.S. Atmospheric River. Next slide, please. So for a bit of an introduction, the mid-May atmospheric river really ended quite a dry period here in the Eastern U.S. and what ended up quite a wet May. There was a connection of moisture for this atmospheric river from the Eastern Pacific all the way to the Eastern U.S. And the Weather Prediction Center played a big role in forecasting that system in advance, from the extended range forecast to the excessive rainfall outlooks and the mesoscale precipitation discussions. There was over a half a foot of rain in a couple of states, and a flash flood emergency did result in 2 elementary schools being evacuated in Western Maryland due to flash flooding. Next slide, please. So this was the extended forecast issued by our medium range desk here at the Weather Prediction Center on May 7th, really focusing on that May 12th to 14th period here in the Mid-Atlantic, but they did highlight the threat for a multi-day Southeast U.S. heavy rainfall and flooding threat with anomalous moisture that'd be pulled from this closed upper level low. And there was a threat for the heavy rain to shift into the Mid-Atlantic by early next week, which would be around that May 12th to 14th timeframe. Next slide, please. So here's a snapshot on May 11th. So this is on Sunday when we really start to see that moisture getting pumped into the Eastern U.S. with a closed upper level low across the Southeast. And you can see that transport of moisture really well from the Western Caribbean, even the Eastern Tropical Pacific, into the Southeast U.S. So that kind of burnt yellow color in the blended total precipitable water is around 45 millimeters, or 1 3/4 inches. So definitely a lot of moisture there in the Southeast at this time. Next slide, please. So right around that time, we did see mesoscale precipitation discussion issued. These products are issued by our MetWatch desk here at the Weather Prediction Center to highlight the risk for flash flooding in the next 6 hours. So Georgia and South Carolina highlighted there. And what we saw in the blended total precipitable water product were PWs, again, 1 3/4 inches or greater. And that was referenced here in the MPD discussion. And that was 2 to 2.5 standard deviations above normal for the middle of May. So definitely an anomalous event setting up here in the Eastern U.S. Next slide, please. So now looking at the excessive rainfall outlooks from Monday through Wednesday, May 12th to 14th, just looking at the day one on what our excessive rainfall outlook looked like. This is the risk of rainfall exceeding flash flood guidance within 25 miles of a point. So it started off in the southeast on May 12th. We had a slight risk for flash flooding from Florida all the way to central Virginia, and a moderate risk there in the urban corridor in South Florida. Next slide, please. Next day, on Tuesday, May 13th, the threat shifted just farther to the north. We had a large marginal risk across the Ohio Valley and Mid-Atlantic, with a slight risk there from eastern North Carolina to central Pennsylvania. Next slide. Yep. And then on Wednesday, May 14th, still residual marginal threat for flash flooding from the Carolinas up to central Pennsylvania. So for a snapshot of what happened from May 12th to 14th, those 3 days with the excessive rainfall outlooks, we ended up with about 65 flash flood warnings in the Eastern U.S. from Florida to Pennsylvania. Definitely with a higher concentration in the Mid-Atlantic. So looking at the Sterling National Weather Service Forecast Office in DC and Baltimore area, Southeast Virginia Wakefield office, and then Charleston, West Virginia, all had 14 flash flood warnings over those 3 days. Next slide. And then flash flood emergencies, there were 3, all in the Sterling WFO area. So looking at the DC, Baltimore areas and all the way west to the Appalachian Mountains. So now looking at some imagery from May 12th, this was when there was that moderate risk for flash flooding in South Florida. And the GOES-East geocolor imagery overlaid with the GLM flash extent density showed some convection to start the day there in South Florida. And then another round of storms toward sunset there that did actually spawn a few tornadoes and high wind reports there in Palm Beach County in South Florida. You'll also note the upper level low there in the interior southeast and the curvature of the convection and moisture heading off the Atlantic into the southeast U.S. Next slide, please. So we recently did get microwave imagery added to our operational workstations and AWIPS at the Weather Prediction Center. And this has been useful for tracking convection coming offshore towards the land. And we saw how all that convection and precipitation was curving into the southeast U.S. In this microwave imagery, you can see through the cloud cover and look at the nature of the convection with those bright red colors and the 89 gigahertz RGB, representing a lot of ice in the clouds and mature convection. And you can see repeating rounds of showers and thunderstorms heading into the Eastern U.S. on the afternoon of May 12th. This is a longer loop looking from Monday into Tuesday, May 12th to 13th. The advected layer precipitable water, which recently became operational from Sierra to OSPO. And you really can see the curvature around the upper level low and the length and source of the moisture plume, again, coming all the way from the Western Caribbean. Very high precipitable water values at all layers coming from that source region. And these PWs were from anywhere from 1.5 inches to 2 inches, pretty much from Florida all the way to the Mid-Atlantic by May 13th. Next slide, please. So this is courtesy of Sheldon Cusselson, who I believe is on the call, looking at May 11th to 13th in review. This was from Florida to about the Carolinas, and in the top left corner with the infrared imagery from GOES and the clean long wave channel, you can see that connection pretty clearly from the Western Caribbean all the way to the southeast U.S. of moisture And in the high level water vapor, you can see that well-defined upper level low. There were up to 8 to 10 inches of rain in Georgia, South Carolina, and Eastern North Carolina from that day, and just a huge connection of moisture from the tropics to the Eastern U.S. Next slide, please. So now getting into May 13th, this is when more of the flash flood emergencies started to occur here in the mid-Atlantic in Maryland and Virginia. This is a snapshot of that same advected layer precipitable water product from May 13th. This is at 13 UTC. And we're looking at all 4 layers here. And when summing those 4 layers, you do have over 1.5 inches of precipitable water. Those areas in black are where intense convection is already occurring. But with the pass, we do see a lot of moisture there getting funneled from the Atlantic right into the mid-Atlantic and perpendicular there to the Blue Ridge and Appalachian Mountains where there's higher terrain. Next slide, please. Sierra also does produce an advected layer precipitable water percentile product. This is based on a 10-year period, weekly climatology, and you can see how anomalous this moisture plume was. And that was noted again in the extended forecast discussion, almost 5 to 7 days in advance, how anomalous this moisture would be. So there in the light pink and then the bright red are 99th percentile or maximum values, which is really evident at the surface to 850 millibar level, and then the 500 to 300 millibar level as well. And you can see the curvature there heading into the Eastern U.S. So this is a popular product to use in tandem with advected layer precipitable water to see how anomalous those events can be. And this is another one that we are going to try and get into our operational workstations at the Weather Prediction Center. Next slide, please. So here's a longer animation from May 12th to 13th, looking at the lower level water vapor band. You can clearly see the spin and curvature of that upper level low as it slowly meandered to the east-northeast across the southeast U.S. And then as the front clears Florida, and all that moisture kind of curving back into the eastern U.S. You'll see a lot of training, especially toward the end of the period of convection in the mid-Atlantic and Virginia, in Maryland, as heavy rain occurred through much of the day on May 13th. Here's the layered vapor transport product. This is another Sierra product that is the advected layer precipitable water product, but with the GFS winds accounted for it. And you can see adding all 4 layers, we definitely have a lot of moisture heading right into the spine of the Appalachians there. It's a little bit small, but in the mid-Atlantic. And when summing all 4 layers, it's about 650 to 700 kilograms per meter per second. And on this day, the HER rapid refresh model integrated vapor transport was actually made available to forecasters, and it matched really well with what that was showing. So it was nice to have that validation with the models and showing that was accurate to depict the highest threat level in the mid-Atlantic. This is another product we as well are hoping to get into our operational workstations for our heavy precipitation forecasters. Next slide, please. So now we are at 14:30 UTC, so just around lunchtime on May 13th, and we're looking at the derived motion winds. Those in the red bars are from 100 to 400 millibars, and it does a really good job at depicting the source of the moisture plume. You can see those high winds at the upper levels, again, even from the eastern tropical Pacific over the Yucatan and Western Caribbean, curving all the way into the eastern United States. If you keep your eyes focused there in Southern Virginia and the Maryland area, you'll see the jet max there of about 70 knots of wind in South Central Virginia. So this is a couple hours before some of those flash flood emergencies. We did see a strong jet there heading into the mid-Atlantic region. Next slide, please. So that was referenced as a concern in the mesoscale precipitation discussion issued around that same time, with a jet streak noted in the derived motion vector winds. And those winds were oriented from from southeast to northwest at 850 millibars. You can see the curvature there with the yellow arrows are perpendicular to the higher terrains here in the mid-Atlantic. So there was a concern for flash flooding in Maryland, Virginia, and West Virginia over the next 6 hours. Next slide, please. This is jumping a little bit later into the afternoon. The solid convection from about Washington, D.C. up through New York, that thick cloud shield moving to the northeast as the upper level low is shifting to the northeast as well, and with some daytime heating and breaks in the cloud cover. You'll notice in the group energy density from the GLM an uptick in lightning activity there in south central Virginia and some higher cloud tops as you move into the late afternoon and into the evening there. So there was a second mesoscale precipitation discussion. Again, those only run for 6 hours. So this one expired and the Met Watch just decided to issue another mesoscale precipitation discussion with that new group of thunderstorms and convection, saying those slow-moving banding cells would lead to significant flash flooding across central Virginia. Again, this was after that solid shield of convection had already moved through, so soils are no longer dry. And looking at the visible radar and lightning detection gave them confidence to issue this mesoscale precipitation discussion into the late evening on May 13th. Next slide, please. So I have this infrared loop, the 10.3 micron channel from 15 UTC all the way to 05 UTC on May 14th. Apologies if it freezes on you like it is for me, but those two red stars there are where the flash flood emergencies were issued. First, from that first mesoscale precipitation discussion in Western Maryland, where there's that red star, that's where the 2 elementary schools were evacuated in the afternoon. And there were 200 faculty and students that were evacuated during that process. And then in southern central Virginia, that was in the late evening with that second area of training convection that developed with the daytime heating. There was another flash flood emergency. There we go. And here's Sheldon as well, a recap for May 13th to 15th, so more of the mid-Atlantic focus. Again, really see a great connection from the Eastern Tropical Pacific there in the infrared imagery in the top left, all the way to the Eastern U.S. and even the Eastern Great Lakes. That picture there to the right that's really small, that's the Westernport Elementary School where there were evacuations. You'll see some boats there evacuating the students. And the MRMS imagery on the bottom right shows 7 to 8 inches of rain fell from central Virginia to Western Maryland, where the elementary schools were evacuated. There was about 4 inches of rain there for the 48-hour period ending on May 15th. Next slide. So in conclusion, the atmospheric river affected the Eastern U.S. in the middle of May with a lot of satellite products tracking the source and transport of moisture all the way from tropics. And the percentile products and standard deviations showed that this was an unusual event. The Weather Prediction Center provided lead time on the hazards possible. Again, it was highlighted in the extended forecast discussion about 5 to 7 days in advance, and then with the excessive rainfall outlooks as the event got closer to 6 hours before with the mesoscale precipitation discussions. We do have more satellite-derived precipitation tools coming to WPC soon. Like I said, layer vapor transport that was presented is one that we're hoping to get configured, along with some microwave sensor-derived rain rates, and even using Gremlin to look at radar reflectivities where there's no coverage, for example, in the southwest monsoon, as we head into that season in the coming months. Next slide. And you can email me at my NOAA or UMD email for any follow-up questions, and I can take any questions here as well. Thank you.
Great. Thank you, Chris. That was a great presentation. I do have a question for you, but first, before I get to that question, I want to remind everybody at this point in the presentation, we can change your layout if you want to click at the dotted area at the bottom of the screen and change it to tiled and hide tiles without video. That way it can be more of an interactive session from here on out. Please feel free, and I highly encourage you to ask questions in the chat box on the bottom right. We ask that you limit responses to 30 seconds, but definitely we encourage participation here. We want you to share any feedback you have on this session or for the Satellite Book Club in a short survey that's being linked into the chat room right now. And a reminder that in 2 weeks, which will be Thursday, June 26th at noon, Galina, hopefully I'm pronouncing this right, Chirikova and Mark DiMaria, both from the Cooperative Institute for Research of the Atmosphere, which is CIRA, are going to present on microwave sounders. And so with that being said, I'm going to ask the first question here. Chris, what satellite products are most referenced at the Weather Prediction Center for the issuing mesoscale precipitation discussions?
Yeah, great question. Thanks, Andy. Definitely a lot of the just imagery bands are referenced a lot, visible or infrared, as well as water vapor channels, but then some of the other products like lightning cast is a popular one in the southwest monsoon, where we have found it can detect convective initiation even a couple hours before the convective allowing models. And then a lot of those microwave sensor inputs to the precipitable water products that I presented, the affected layer precipitable water, layer vapor transport, to see the source of the moisture, the length, and the intensity.
Great, thank you, Chris. I want to mention that Sheldon, he put some links into the chat room as well regarding the effective layer precipitable water percentile rankings and some other useful information. So thank you, Sheldon, for that. We have a question from Jarrell Torres. His question is, from the precipitation and flooding during this event, did you check out the VIIRS flood map product that runs at about 375 meters? Does WPC have access to that product in AWIPS?
Yeah, so we don't have access to any of the flood mapping products in AWIPS, VIIRS, or the ABI. It's definitely something I want to introduce to forecasters from a verification perspective, but also when we're looking at doing our excessive rainfall outlooks, looking at areas of concern. Like we already highlight urban areas for lower flash flood rates and things like that. So it's something definitely want to look into more, Jarrell.
Thanks, Chris. This is a comment from Jeremy Geiger. This event was quite interesting. It started as a flash flood event and then became a longer duration river flood event along the Potomac River. Sheldon also has another comment. For May, this far north, this is an unexceptional event. Cannot imagine how much more rain would have fallen if this was August or September, like with Helene last year. From Dan Lindsay, are WPC forecasters looking at any of the various experimental AI models, for example, for day 3 plus QPF?
Yeah, so we do have the European AIFS model in our operational workstations, or AWIPS, and then we also do access on the web a variety of other AI and machine learning models, like the GraphCast, those produced by Microsoft, and some other, I think 2 or 3 others. I can formulate a list for you, but it is something we're looking at, especially doing post-event verifications to see how they're performing against other global models that we've already been using.
Great, thank you, Chris. I'm actually excited about the opportunity for some of us here at the GEO program to come visit WPC and OPC next month to have some of our satellite experts sit down and learn things and operations from both WPC and OPC. So we're excited to have that opportunity to do that. Do we have any other questions from the folks out there? Oh yeah, another from Darrell. Which satellite rain rate products does WPC have access to? Like blended rain rate, possibly CMOR 2 and others?
Yeah, so we do have the blended rain rate in AWIPS as well as the GOES Enterprise rain rate products. CMOR 2 is something that our international desk definitely wanted, and I couldn't remember if it was AWIPS compatible, the new version last. I probably should follow up on that one, but we do have a couple of the rain rate products already in there.
Okay, thank you. Another question is, what spatial resolution do you think microwave data will be useful?
Yeah, I'd have to definitely talk more with the forecasters. I know it's more coarse than a lot of our, regular imagery. I haven't heard any complaints about the spatial resolution we have it at, but it is also one of those products that are newer to our operational workstations with some training. So I think there's some opportunity there to get feedback as forecasters get more familiar with the products.
Great, thank you. Does anybody else out there have any other questions or comments for Chris? Mike, go ahead. Mike, you're muted. Mike, do you have a question? You're muted.
Yeah. Yeah, and Andy, mics are muted during the call. So.
Oh, okay. So Mike, you want to go ahead and ask the question in the chat? Any other question while Mike's typing into the chat? Mike, we cannot unmute people on the call. You'd have to type it in the chat. Chris, this might be while we're waiting on him. So WPC, do you envision, like, with improvements that satellites might have in the future, some different products that you might be able to, that they might be able to pursue?
Yeah, I know, I guess it's not, well, I know like GeoXO, same with Meteosat 3rd generation, has that band that you can see lower level water vapor concentrations and the moisture transmittance. I think some of those gradients, seeing to detect convective initiation ahead of time, could be really useful. It's something we're really excited about seeing. That's top of my head. There's also more of those machine learning. I think products that take in multiple data sets like Lightning Cast or Gremlin seem to have a lot of value and interest with our forecasters.
Okay, great. Dan has a follow-up question from AI. He heard from others that AI models were less good at QPF compared to more large-scale parameters like 500 millibar heights. Is that consistent with what you're hearing from the forecasters?
Maybe slightly. I can't say for sure. I know that for this past event that happened in Texas yesterday and today, for example, the AIFS was too far south, but I know for 500 millibar heights, they have performed well with cutoff lows and things like that here in the East before some of the regular numerical weather prediction models. So that seems to track, but I can't say for sure.
All right, thank you, Chris. Anybody else have questions for Chris? Mike's comment was, thanks to Chris for covering an East Coast AR event. The significant rain outlooks you showed early on seemed to really under forecast the rain. How far ahead were they?
Yeah, so for the day one excessive rainfall outlooks with the slight risk, that still does account for some flash flooding. I can't remember what the percent threshold was in my chat, but definitely there was some upside potential. I think I'd have to look back at some of the discussions, but we are in the future adding categories for like 25% to kind of bridge that gap between a slight risk at 15% chance for flash flooding within 25 miles to moderate at 40%. So it might have been one of those that were marginal and they picked one category or the other that we're hoping to resolve in the future.
Thanks. Mike says thanks and great presentation. We have a comment from John Forsyth. You also mentioned NOAA quick sounder microwave, the microwaves that are planned for 2026 launch will improve the temporal sampling for ALPW and other products.
Yeah, we've already put that as a request to be in the MIRS algorithm to keep our ALPW and light vapor transport products good for us. So.
Great. Jeremy mentions he knows the model guidance had the magnitude of QPF shown in the area, but it was off on the location of the QPF max. So it's good to know at least they they knew it was going to be some sort of bullseye there. He said that it's always hard to place those features. You know, just like with snow, right? It could be just like 10 miles off, and you're like, hey, I was supposed to get 3 inches of snow, and I got 1. It's always tricky with the high resolution events.
Seemed to track with the event this week in Texas. It had, I think, the right magnitude, but was a little too far south.
Any other questions or comments for Chris? Yeah, I mentioned I favored the Blue Ridge instead. Yeah. Okay, I'm going to pass this all back to Brian.
Hey, all right, Andy, thanks very much for facilitating today. And Chris, thank you for that great presentation showing a lot of GEO and LEO satellite data applicable to this high impact flooding event. We've barely dried out here. But I really appreciate that recent case study too, fresh in our minds. As Andy advised us earlier, please join us a week from today when Galina and Mark will be presenting on microwave soundings. We look forward to seeing you back right here. With that, thanks all for your participation, and we'll wrap up today's book club seminar right here. Thank you.